Hi my dear students, myself Kedarnath. In this session I'm going to explain some more shortcut formulas, okay, in binomial theorem. So how to find number of terms in a given multinomial within 2 seconds. So what is the formula, shortcut formula? So number of terms in given multinomial x1 plus x2 plus x3 and so on plus xr whole power n is n plus r minus 1 c r minus 1. See here n denotes what? Index or power or exponent. R denotes what? Number of terms in the base. Number of terms in the base. For example, if you take binomial only a plus b whole power n. Well, how many number of terms are there? You can use the formula or else you know already directly. What is that number of terms in this? N plus 1. Number of terms in the expansion of this binomial is how much? N plus 1. So number of terms in the expansion of trinomial a plus b plus c whole power n. So here what is our value? 3, because base contains how many terms? 3 terms. So here n is nothing but n only. Then how many terms you will get? So according to that formula, n plus r is 3 minus 1 c 3 minus 1. So that means what you will get? N plus 2 c2. Okay. For example, if I take one more trinomial a plus b plus c whole power 10, then number of terms in the expansion of this trinomial will be what? 10, n is 10, n value is how much? 10, r value is how much? 3, because number of terms in the base is 3. So formula is what? N plus r minus 1 c r minus 1. So that means you will get 12 c2. So what is 12 c2 value? 66. So next you take one more example, say a plus b plus c plus d plus e whole power 100. So number of terms in the expansion of this multinomial is, particularly here, number of terms in base is how much? 5 terms are there. 1, 2, 3, 4, 5. So r value is how much? 5. N value is how much? 100. So because index n value 100 only na. So what is the formula? Number of terms formula, n plus r minus 1 c r minus 1, that is 100 plus 5 minus 1 c 5 minus 1. That means how many terms you will get? 104 c 4. So next, analysis of binomial expansion. So consider 1 plus x whole power n expansion. Here c0, c1, c2 and so on. Cn denotes what? They are the binomial coefficients of order n. So that means here cr is nothing but ncr. That means c1 is nothing, c0 is nothing but nc0, c1 is nothing but nc1, c2 is nothing but nc2 and cn is nothing but ncn. So first question. So what is the sum of these binomial coefficients of order n? Okay, so put x is equal to 1 here. So put x is equal to 1 to get sum of the binomial coefficients. To get sum of the binomial coefficients, put x is equal to 1. So if you put x is equal to 1, then LHS becomes what? 1 plus 1 whole power n. RHS becomes what? C0 plus C1 into 1, C1, C2 into 1 square, C2 and so on, Cn into 1 power n, Cn. Here 1 plus 1 whole power n. So on simplifying this, what is C0 plus C1 plus C2 and so on plus Cn is equal to, on simplifying this, what will get? 1 plus 1 whole power n is 2 power n. So this is the important result. So sum of the binomial coefficients of order n will be what? 2 power n. For example, so what is 17c0 plus 17c1 plus 17c2 plus and so on 17c17? So the answer will be 2 power 17, because these are the what? Binomial coefficients of order how much? 17 only na. So then sum of the binomial coefficients of order 17 will be what? 2 power 17. So next, next you put x value minus 1, you will get one more result. Put x is equal to minus 1. Then here if you put x value minus 1 RHS, what you will get? C0, C1 into minus 1 minus C1, C2 into minus 1 whole square plus C2, next to minus C3 and so on. Finally minus 1 whole power n into Cn. So if you put x value minus 1, what will get? 1 minus 1 whole power n. 1 minus 1 whole power n is 0. So this is the second important result has to remember. Next, to get next result, adding equation 1 and equation 2. On adding equation 1 and equation 2, see here, if you add equation 1 and equation 2 here, C0 plus C0, 2 times of C0. So plus C1 minus C1 get cancelled. So plus C2 plus C2, 2 times of C2, next to 2 times of C4 and so on is equal to, you will get 2 power n plus 0. So take 2 common and divide with 2, then you will get C0 plus C2 plus C4 plus and so on is equal to 2 power n plus 0 is 2 power n divided by 2, which is equal to 2 power n minus 1. So NC0 plus NC2 plus NC4, they are what? Even binomial coefficients. So sum of the even binomial coefficients of order n will be 2 power n minus 1. Okay. Similarly, if you do equation 1 minus equation 2 and then after divide with 2, then you will get C1 plus C3 plus C5 plus and so on is equal to 2 power n minus 1. So NC1, NC3, NC5, nothing but what? They are odd binomial coefficients. So that means sum of the odd binomial coefficients, sum of the odd binomial coefficients of order n will be 2 power n minus 1. Okay, so these are the 4 important results you have to remember. Sum of the binomial coefficients of order n will be 2 power n. Sum of the even binomial coefficients of order n is same as sum of the odd binomial coefficients of order n, which is equal to 2 power n minus 1. And here alternatively plus minus is there, so that sum will be what? 0. These are the 4 important results you have to remember. Now look at the problems based upon these 4 results. Okay, so look at the example problems based upon the above 4 results. So here what they are asking, 15C1 plus 15C3 plus 15C5 and so on plus 15C15. That means what they are asking, sum of the odd binomial coefficients only. Sum of the odd binomial coefficients. What is the formula? 2 power n minus 1. What is n denotes? Order. So what is n value here? 15. Okay. So sum of these odd binomial coefficients formula 2 power n minus 1. Here n value is what? 15. So 2 power 15 minus 1, that is equal to 2 power 14. Similarly, the second one, they are asking what? Sum of the even binomial coefficients only. See, 20C0, 20C2, 20C4 and so on, 20C20. That means they are asking only even binomial coefficients. So formula will be same only, 2 power n minus 1. Sum of the even binomial coefficients of order n will be what? 2 power n minus 1. Here what is n value? 20. So 2 power 20 minus 1, what will get? 2 power 19. Similarly, here what will get? Odd binomial coefficients only, 2 power 10 minus 1, 2 power 9. And similarly here what will get? 2 power n plus 1 minus 1, because here order is what? N plus 1. So thus the answer is 2 power n. Here what is the order? N minus 1. And they are asking what? Only sum of the odd binomial coefficients. So formula is what? 2 power n minus 1. But here order is what? N minus 1. So order minus 1. So order is here n minus 1 minus 1. So 2 power n minus 2. So look at the next problem. Find sigma k is equal to 0 to 10, 20 C k. So first expand this summation, then you will come to know how to evaluate that problem. Okay. So first let it be S. So let S is equal to sigma k is equal to 0 to 10, 20 Ck. Now we have to find the value of S. Okay. So just expand sigma, what you get? 20 C0 plus 20 C1. That means if you put k value 0, 20 C0. Next k value 1, 20 C1. Next what you get? 20 C2 plus and so on, 20 C9 plus 20 C10. Am I correct? Okay. So if it is up to 20 C20 is there, then formula is then a 2 power n formula according to that 2 power 20, but it is not up to 2 power 20 C20. At least if it is odd binomial coefficient or if it is sum of even binomial coefficients is there, then at least you can write formula 2 power n minus 1 using that formula 2 power 19. But it is neither sum of the odd binomial coefficients nor it is a sum of the all binomial coefficients of order 20. then how to evaluate, how to find the sum, how to find this sum? So in such case, you recall this formula. NCR is same as NC n minus R. Number of ways of selecting R objects from n objects is same as number of ways of deselecting n minus R objects from n objects. So using that formula, 20C0 is same as 20C20, am I correct? 20C1 is same as 20C19, 20C2 is same as 20C18, and so on. 20C9 is same as 20C11, 20C10 is again same as 20C10. So now adding these, on adding what you'll get, s plus s, 2s. So right here like this, 20C0 plus 20C1 plus and so on, 20C9 plus 20C10 over this line, next this line, right in reverse order. So you leave this term first, right in this order, what you get, 20C11 and so on. What you are getting, 20C18, 20C19, 20C20, correct? And what we left, one more term, 20C10, you write here, this 20C10 I am writing here. Now if you observe from this sum, whatever the sum inside the bracket, so that is nothing but sum of the binomial coefficients of order 20 only, na? So that sum will be what, 2 power 20 plus 20C10 as it is. So thus s is equal to what you'll get, 1 by 2 into 2 power 20 plus 20C10. So that was the answer. Next problem, find this sum. So just like above problem. So let s is equal to 15C0 plus 15C1 and so on, 15C7. Here also it is neither sum of all binomial coefficients, nor it is odd binomial coefficients, nor sum of even binomial coefficients. So in such case, what I told, use NCR is equal to NC n minus R. So s is equal to 15C0 is same as 15C15, 15C1 is same as 15C14, and so on. 15C7 is same as 15C8. Add these two, s plus s, what do you get, 2s. So first write this sum in this direction. So what do you get, 15C0 plus 15C1 and so on, 15C7. And next to sum you write in this direction, plus 15C8 plus 15C9 and so on, 15C14 plus 15C15. So now if you observe, it is the sum of binomial coefficients of order how much, 15. So thus this sum is nothing but 2 power n, so 2 power 15. So s is equal to what you will get, 2 power 15 by 2. So 2 power 15 by 2 is 2 power 14. So look at the next problem. So if this whole sum is equal to 2 power k by n factorial, then what is k value? So to get that k value, better you cross multiply n factorial. Then what you will get, 2 power k is equal to n factorial by 1 factorial into n minus 1 factorial plus n factorial by 3 factorial into n minus 3 factorial plus n factorial by 5 factorial into n minus 5 factorial and so on. Just what I did, I cross multiplied n factorial. That means each term you have to multiply with what? N factorial. That is what I did here. So 2 power k is equal to n factorial by 1 factorial into n minus 1 factorial. It is nothing but what? NC1 only. NCR formula is what? N factorial by r factorial into n minus r factorial only. Na? So n factorial by 1 factorial into n minus 1 factorial becomes what? NC1. Similarly, next term is NC3, next term is NC5 and so on. So 2 power k is equal to, if you observe RHS, that is nothing but sum of the odd binomial coefficients. Sum of the odd binomial coefficients of order how much? N. So what is the formula? 2 power n minus 1. So thus k value is how much? N minus 1. K value is how much? N minus 1. So same model, try this problem. If 1 by 1 factorial into 16 factorial plus 1 by 3 factorial into 14 factorial plus 1 by 5 factorial into 12 factorial plus and so on is equal to 2 power k by 17 factorial. Then what is k value? So this is the previous year JW mains problem. So try this problem. So with this I'm going to close this session. I hope you understand the session. If you like this video, share this video to your friends and ask them subscribe my channel to get more number of videos. Okay, stay home, stay safe. Thank you.